Welcome back to Math 171 Pre-Calculus Algebra. In this video, we're going to take a look at how to solve a system of equations in 3 variables. So, you could use the substitution method to solve a system of equations in 3 variables. However, it is a complete pain to do, so I'm not going to show you how to do it. Instead, we're going to use the addition method. So let's take the system of equations 5x minus 2y minus 4z equals 3. 3x plus 3y plus 2z is equal to negative 3. And minus 2x plus 5y plus 3z is equal to 3. So, now before we had the situation where there were 3 cases with the linear equations in 2 variables that we could talk about the different forms solutions could take. There's many more things that can happen when we have a linear equation in 3 variables. Because a linear equation in 3 variables actually depicts a plane in 3-dimensional space. So, I believe in today's lessons, all that we have are going to be situations that the 3 planes intersect at a single point. So, the method we're going to do is we're going to take a pair of these equations and use them to eliminate one of the variables. So we'll take the first 2, in this case, 5x minus 2y minus 4z equals 3. And then I'm going to go ahead and take the step of multiplying the second equation by 2 as I write this down. So that ends up being 6x plus 6y plus 4z is equal to negative 6. So that's 2 multiplied by the second equation. Now I can go ahead and add these together and get 11x plus 4y equals negative 3. But now what I need to do is take another pair of these equations and eliminate the same variable from them. So let's go ahead and take the second and third equation, so 3x plus 3y plus 2z equals negative 3, and negative 2x plus 5y plus 3z equals 3. So, we'll need to multiply both of those equations by something to get the variables to cancel. I'm going to go ahead and multiply the first one by 3, and the second one by negative 2. So that's going to give me 3x. Oops, I'm sorry. Going to give me 9x plus 9y plus 6z is equal to negative 9. And then 4x minus 10y minus 6z is equal to negative 6. Adding those equations together, I get 13x minus y equals negative 15. So now what I'm going to do is take these two equations, 11x plus 4y equals negative 3, and 13x minus y is equal to negative 15. And now we can use any of the methods that we used before to solve a system of equations in two variables. I'm going to go ahead and use the addition method on these. So, if I multiply the second equation here by 4, it's going to give me, so I still have 11x plus 4y equals negative 3. And now here I get 52x minus 4y is equal to negative 60. Adding these equations together, I get 63x equals negative 63. So x is equal to negative 1. Now, to finish this, I'm going to back substitute a couple of times. And I apologize for the fact that this ends up being all over the screen. So first I'll take care of 13x minus y equals negative 15. We already established that x is negative 1. So this becomes negative 13 minus y equals negative 15. Add the 13 to both sides. I get negative y equals negative 2. And then divide both sides by negative 1. I get y equals 2. So now I have x equals negative 1, y equals 2. Now I need to substitute that into one of my original equations. And I think I'm going to do it with the 3x plus 3y plus 2z equals negative 3. So we get 3 times negative 1 plus 3 times 2 plus 2z is equal to negative 3, which ends up being negative 3 plus 6 plus 2z equals negative 3. Combining like terms, 2z plus 3 equals negative 3. I can subtract 3 from both sides. I get 2z is equal to negative 6. Z is equal to negative 3. And now I can finally put everything together. The x equals negative 1, the y equals 2, the z equals negative 3, to state that my solution set is negative 1, 2, negative 3. So that concludes this video. In the next lecture that I'm going to post, but this will be later, we're going to take a look at a much more streamlined way that you can do this process that'll also help us out in solving systems of equations that have more than 3 variables. But that concludes this video, and I will have more videos for you by the end of the weekend.